Good morning, everyone. Thank you for coming. I hope you're properly caffeinated and ready to go. And this has been a great week. How are you enjoying CppCon so far? Good? Awesome week. Hope I am not going to ruin that for you. So a few months back, my friend Simon tweeted this, and I immediately identified with the problem. But I said I'm going to roll with it. I'm not sure if I'm going to do that again, but and my daughter keeps telling me that I do look like Gru, so if it fits. Just in case you're disoriented, this is the Victor roadmap for the week. You're in this talk. If you want to catch any of the other ones, you'll have to wait for the videos. And let's get started. We're going to talk about better tools in your Clank toolbox. And why am I talking about this? First of all, I've been coming to these kinds of conferences for years now, and I've always had sort of a tool envy, so to speak. All the cool kids hang around the Clang cucumber water. And I was kind of jealous and wanted to get in on the action and try out some of the tools around the Clang ecosystem and play around with them. But historically, I've been in a team that developed Windows-only applications, and we've been working on our product for 15 years now, and we're knee-deep in COM and in Visual Studio. And I thought I would never get an opportunity to really try out in production cool stuff like Clank-tidy or any of the Clang-related tools. So about a year ago, my friends and I started playing around, more like a hobby with, we started with Clang format basically, and we tried to experiment and see how we could use Clang tools on Windows and see if we can make them work and integrate them in our workflow. And this talk is organized in mainly 3 themes. And the first part, I'm going to be talking about exclusively about tools. And I'm not sure if all of you have been to the welcome reception on Sunday night. We had a poster expo. You can still see some very cool posters in the main hall there. And you can probably see this giant poster there. It's all about retrofitting modern C++ 17 features in older code bases and how we got around to implement our own custom tools to help us with that. So I'm going to spend a little bit of time talking about Clang Power Tools. And Clang Power Tools is basically bringing all the goodness of the Clang tools ecosystem for Visual Studio users. And I'm talking explicitly about tidy, compilation, and of course Clang format. And it works in latest Visual Studio versions as well as the previous version. It's an extension for the IDE. It's free and it's open source. So it does help with this workflow. Initially, we developed it internally, and like I said, we tried to play around with it and see if it can really help us pinpoint issues and improve our code base. But after a while, we decided to share it with the community, and we chose exactly 1 year ago today. I couldn't have scheduled this better myself, even if I tried. So exactly 1 year ago today, I had a session here at CppCon where we announced this tool that we open sourced and made available in Visual Studio Marketplace. So how are things standing 1 year after this launch? We've been surprised by the popularity and the enthusiasm in the community around this tool, and people embracing it and trying it on. And sometimes it failed for them. They submitted tons of bug reports, and we tried to stay on top of them and fix all the issues that we encountered out there. People got very creative and used it in contexts far beyond our imagination, and we've seen project configurations that well exceed reasonable complexity limits. So it's amazing what people can do with MS build files and Visual Studio property sheets. So it's definitely been a learning experience for us, and surprisingly, I can confidently say that debugging issues and seeing other people's configuration scenarios around trying to use this tool ironically made me better understand how Visual Studio works and how MS Build works and how to properly organize and configure your property sheets. So definitely a learning experience for us, and we very much like to thank the people that got involved very early on and helped out, being with their suggestions or feedback or even pull requests and ideas. I want to give a shout out to my friends Gabriel and Ionuț, that really they're the brain behind this wonderful product. So if you're interested, you can definitely get involved. The project is open sourced. At least you can submit bug reports if you try it and it doesn't work for you, and we'll try our best to make it work. So we started with a PowerShell script. To be honest, we didn't start with the productivity IDE integration scenario. So we initially started building a PowerShell script, and we still maintain it today, and we use it for CI automation because we want to keep building our code base with Clank to see that we don't have any regressions on that front. And we've enriched this script, and we're actually dogfooding ourselves. And it works directly on Visual Studio project files, or MS Build for that matter. And it does support compilation and tidy workflows. It does not do any round-trip conversion, and it doesn't generate JSON Clang compilation database. We do have that as a feature request, and we're thinking about implementing that. But definitely, we would try to automate this process of generating the compilation database and avoid putting the pressure on the user in terms of describing the project configuration by hand. So it does support parallel compilation of translation units, and it does support precompiled headers. This is very big for us. We make extensive usage of precompiled headers in our project, and it does help speed up the builds. And of course, it automatically extracts all the settings from Visual Studio projects, include paths, platform toolsets, directories, PCH information, everything. Has a very rich interface in terms of automation. These are just a few of the input switches that it supports. And like I've said, we're very interested in keep using this in our workflow, and we've definitely improved the script as a consequence of this. You can run the PowerShell directly by specifying all the parameters required. So you do gain low-level access and configurability over every little detail of its behavior. But it also supports a configuration file, so you can safely configure any project-specific behaviors or parameters that you can put in source control and share with your teammates. And this is how it would look like. Some very simple examples. For example, compiling a whole workspace. If you don't give it any parameters, it actually tries to detect all the solutions in the current directory and browses all the projects and compiles everything in there. And you can be explicit about it. You can ignore on certain criteria with regular expressions and everything. Basically, what you would expect from this kind of a tool. And you can run tidy workflows on specific projects or specific files. And you can even tell it to automatically apply the fixes. So basically, it just pipes down all the expected tidy commands onto Clank-tidy itself. This is how a configuration file might look like, a very simple one. This is actually the one that we're using internally, more or less. So you can definitely avoid giving all those switches every time. Very important for us, we do use Jenkins for CI automation. And the Jenkins PowerShell workflow is very important. I just want to give you a very quick overview of how you would configure something like this. You would need to install the Jenkins plugin for PowerShell, for example. That's in Jenkins plugin library. You would need to configure a PowerShell job as a build step. You can add the commands. This is where you can be very specific for your project needs or your build job needs. We can even make it be triggered by an STM change or something like that. The workflow that works best for us is ensuring that every change on development branches passes the pipeline, and we don't have any regressions in terms of the project actually being compilable with Visual Studio, but not compilable under LLVM. So we do try to make sure that each pipeline passes only if the LLVM build actually passes. We even have triggers. We use Slack internally, and we even use notifications about build failures around this Clang job. Even emails. Some people prefer to receive reports via email rather than Slack. The built-in output and errors are right there in the email content itself. And of course, the thing that really touches the everyday work of the developers on our team is the integration in the IDE. And this is where the Visual Studio extension comes into play. It's available in the marketplace. You can just install it. It auto updates, of course. Highly configurable. You can basically tweak every knob in there. And you can even pass flags directly to the GCC driver for Clang. And you can be incremental in your approach in embracing LLVM compilation. You can suppress lots of warnings in the beginning, and as soon as you're able to fix more stuff and strive towards ISO standards compatibility in the code base, you can be more strict and eliminate some of the ignored warnings along the way. You can be verbose and see detailed output when stuff doesn't work, and investigate dependencies within the projects and problems within contextual variables in your MS build files and see problems there. For the tidy workflow, we found that tidy workflow works best for us in manual scenarios. So we run it occasionally and try to see various passes, and we're being very selective about the actual checks that we run, and we don't run everything all at once because we want to be very explicit about analyzing a particular kind of, for example, modernization pass. let's say we're focusing on range 4, or we're focusing on, I don't know, equals delete or default constructors, or something like that. So we're actually using almost exclusively the auto fix option. So we're very much relying on our Git GUI to see the changes and examine the changes carefully before we accept any of the automated fixes applied. We do have most of the checks built in, but you can, of course, specify them explicitly, for example, using wildcards or selecting multiple passes at once. The integration in the IDE itself is in the usual places you would expect to see it, contextually on a per source file basis, per project, but either selecting multiple files or compiling or tidying up a whole project or a whole solution. So in the usual places you would expect to see such an integration. An interesting part in the integration scenario, the one that I love to use, is that we do have a setting by which each time you successfully compile a source file with Visual Studio, it automatically tries to compile it with Clang in the background, because usually we see problems there. So if it successfully passes Visual Studio compilation, which is what every developer on the team expects, you immediately see if it's also OK under Clang. And of course, the IDE integration is natural, and uses the standard output panes and error panes, and has navigation to issues, and you can filter them out, and you basically leverage all the power within the IDE itself, as if this would be the de facto compiler in the editor itself. For example, if we're analyzing a static analyzer report, you can see the actual information, the output from tidy in the output pane. Sometimes it's a little bit difficult to reason about such an output in this dense textual format in the output window. Our plans are to surface such information in a much more friendlier way, as tooltips hovering the code itself where the problems reside, and maybe even implement something on top of preview windows like code lens and much fancier GUI features in the IDE itself, such that you would have much more cleaned up information about the analyzer report or the warning or the error in such particular case, and it would be contextual to where you're actually focusing on in the source code. So, because we find this is rather difficult to digest, especially if there are many warnings issued by the analyzer, and yeah, it's kind of difficult to follow. But why do we care about all this? Well, the reason we care about this is we've been working on our code base for 15 years now, and in some parts of it, it really shows. It started pre-C++ 11, of course, and when we are dealing with millions of lines of code, it's unreasonable to expect to change anything just for the sake of change, and it's out of the question to do it manually. So we've been very happy to be able to leverage modernization passes from Clank-tidy and be able to do transformations at scale on our source code. And this has been very important for us in terms of morale more than anything else. It's much more pleasant to work on a code base that looks and feels modern, and uses modern constructs. And we've always been on the bleeding edge. We've always upgraded to the latest and greatest from Visual Studio. But it's very straining on the eye to see parts of a source file with leveraging modern features and modern library facilities and language features. And within the same file, you see some old, contrived, ugly constructs from C++ 98. And you want uniformity in that regard. And being able to do modernization passes at scale actually let us to have a more cleaned up source code and uniform. For example, a very simple thing like think about range for loops and avoiding all the long lines of complex iterators and combining range fors with auto or something like that. So definitely very pleasing, and it did help morale. And although this kind of tool induces friction within the team when adopting it initially, because you do have to deal with all kinds of new warnings and errors that you didn't see before. And yeah, type name appears a lot in warnings. So that's just because MSVC compiler didn't have two-phase lookup for 20 years. So what are you going to do? It is frustrating when you're getting in, but the team was very receptive in embracing this tool and tolerating all the warnings and issues that they had to fix because of the benefits and the end result being a much cleaner and modern looking code and being able to actually enjoy programming modern C++. So we've been doing that, and we're very happy with it. I always like to probe the room and see how far along are we on standards usability. Any of you stuck on old compiler toolchains? Few of you. C++ 11, I still consider this old now. OK, 14, about the same people, and 17 now. Oh, not bad, not bad. Yeah, not bad. So, yeah, we want to get there, and we need tools to help us because, like I said, it's not pleasant embracing new features and giving special attention and love to certain parts of your code base and have all the other millions lines of code looking like crap. So you do need tools to help you there, and yeah. So the second part of my story is about massaging the code. And basically, you do this for two purposes. One, I mentioned earlier, is that you do want standards conformance, even if you're not doing any cross-platform or cross-tool compilation. So you do want ISO standard C++ conformance, just for the sake of being future-proof and not have any surprises when your compiler gets updated. So the other thing is you want to find bugs and subtle things that you've been ignoring for years. I know I've seen some ignored warnings in my code base. So as a rule of thumb, we do use W4 and WX. So we treat every warning as error, and we're using level 4. But we do have certain places where we explicitly ignore some warnings. We know why. Yeah, sure.
I'm just wondering if you're to the point where you can use permissive minus yet.
This is my next slide. You're thinking ahead. So yeah, we're explicitly ignoring some warnings, definitely. And this is interesting when compiling under Clang. Sometimes you need to get around that too. And regarding permissive minus, we're trying to get there. We're not there yet, but I am not feeling guilty because of this. Yeah.
What does permissive minus do for those of us who don't know?
Yeah, good question. What does permissive minus do for me? Permissive minus basically gives you the good compiler from Microsoft. It's the one they don't want to tell you about. So I think it's on by default for newer projects, but it doesn't get upgraded for your old projects. So this flag basically enables the modern compiler, the one that actually has an AST and two-phase lookup and supports all the fancy const functionality. And the reason it's an explicit flag is that it breaks everything. So the main thing that's problematic for us, we've been fixing permissive minus issues in our code base, but the problem, big problem is the Windows SDK. They're making big strides in that direction. For example, the CppWinRT subpart of the Windows SDK, that CppWinRT is now part of the Windows SDK, by the way. It actually compiles, so the newer modern parts of the SDK are all good. For example, most of the UWP APIs for programming the Windows runtime, those are in good shape. But some of the ugly older ATL words in the Windows SDK don't compile under permissive minus, not yet. And they're trying to do their best, but it's a problem of synchronization between teams. So they're totally different teams within Microsoft. There's the Windows, the old Windows division. Now it's something else. At least it's called something else. So they're shipping independently. So they're doing their best to fix the issues, but at the same time, the Visual C++ team works hard to push and implement all the cool stuff in the C++ standards. So they have to be strict about it and enforce these requirements under permissive minus. So basically, not flipping on permissive minus gives you the ability to access most of the C++ 17 modern features in the compiler, but still in a Microsoft compatible way. So it's the permissive minus disables all non-standard extensions in the Microsoft compiler. Everything that used to compile, and they do need to compile the whole Windows and SQL and Office. Think about how much code is in there. And they're not using Clang Power Tools to modernize it. So, yeah. So it's a lot of work. Fixing permissive minus issues is not, and it's not a small task. And the thing that we noticed for our code proper, ignoring the SDK dependencies, is that because we fixed all the issues and all the warnings triggered by Clang, we didn't have any permissive minus issues. So we're in good shape. So we have been, at each major upgrade, we've been using the Clang frontend since version 3.9. And at each upgrade, 5.0, 6.0, 7.0 now, new warning classes were triggered on by default, and we're actually using WAll in Clang as the default for our builds. And we don't enable any, except the preprocessor, any Microsoft-specific Clang flags. And we're striving for W extra, but we're not there yet. We still have a lot of aggregate structures that we do need to fix and fill up with nulls. And because of the fact that we've started and enforcing and fixing issues reported by the Clang frontend, we didn't notice any permissive minus issues in our code base, just related to the SDK usage. And a big shout out for the STL team. The Microsoft STL actually compiles cleanly under permissive minus, and actually requires Clang 7 in the latest versions. So we did encounter some issues around COM GUIDs, and those were fixed in Clang version 7. Okay. So like I said, it all started with Clang format. It's very easy to get in, very attractive. And building on the success of the adoption of Clang format in the team, we gained courage to experiment with tidy, and this yielded tremendous benefits for our code base. We encountered a lot of subtle bugs and things that either we ignored under the Visual Studio compiler, or that things that MSVC blatantly, completely ignored and happily compiled. And of course, a lot of best practice kind of things, like uniform usage of override and not having any surprises around renaming stuff in your base classes and interfaces. And actually, this is one of the most impressive modernized passes we've ran over the code base in terms of sprinkling overrides in all the right places, and in this way ensuring a lockdown on being able to confidently rename stuff in your interfaces in your base classes without any surprises. And also, you want uniformity. I hate it when I see a class with 10 methods and just 2 of them are marked override and all of them are virtual. So I don't want to see that. And tidy really helps here. So it was difficult to start out, but we were determined, and it did pay off for us. We've encountered tons of issues. Some of the changes were mechanical in nature, like the type name, the missing type name, and the dependent name lookup. What are you going to do? You have to sprinkle type name everywhere. But those are of no benefit for us. But you have to do those as well. But other issues like encountering near misses in virtual function names, or functions that actually didn't override anything, although you thought they did. So we did find quite a few of those. So, and yeah, I mentioned this earlier. And why are we encountering this? It's kind of easy to get into this problem. If your toolchain allows you to use non-standard constructs or some fancy language extension, and I'm not picking just on MSVCs here, I'm just using it. But same goes with GCC, for example. If you're allowing programmers to use some non-standard construct, they will use it, given the sufficient amount of time. And you're stuck with it. So if your compiler gets more strict and, for example, needs to implement correctly requirements in the new standard, let's say under permissive minus, you're gonna encounter those issues and you have to deal with them. Otherwise, you can move on. So I talked about the modernizers, and the readability also has quite a few checks that we found very useful. And of course, static analysis. Visual Studio has great integrated static analysis, and it does have the CPP core guideline checks right in there, but it never hurts to have more. But this is the kind of thing that comes with lots of false positives, and you have to really look for the needle in the haystack there. So I thought that we would just examine just a few examples that we've encountered. For example, frequent offender, delete without a virtual destructor. So yeah, it's kind of difficult to figure out when you have a deep class hierarchy, but yeah, Clang immediately picks this up. And for example, here, overload virtual. So we actually had the virtual functions that had a slightly different signature. And loop induction variable, or in this case, an iterator was incremented both in the loop header and in the loop body. I don't know how that escaped code review, but Um, Quite a few of these pessimizing moves, quite a few of these we found in our code base. Yeah. And anybody needs to pick on those? It's all clear why Clang protested there. I don't need an aside about RVO and stuff like that, right? Okay. And tons and tons of this one, rewarder. So people were not very consistent in declaring their initializer lists, and we had to fix a whole bunch of these. So this was highly unpleasant. So yeah, and in some situations we actually encountered initialization dependency problems that were dormant there. So this was extremely yucky. Missing field initializers, a few of those, not very serious. Another frequent offender, double user-defined conversions. We had a ton of those, especially around the strings and string literals and stuff like that. So we did had to fix a lot of those, and it was tedious. I won't lie to you. Another frequent one, delete with no virtual destructor, but this time around shared pointer. Quite a few of those, and people didn't properly annotate their interfaces, and they had shared pointers around interfaces that didn't have any virtual destructor. So quite a few of those as well. Another situation here around a simple interface with unique pointers this time. So basically the same issue as before. A lot of this. How many of you are still using old enums? Yeah. I can tell you how many of these we found. Use the wrong enumeration being used in the wrong context. They sound the same, but it's not from the same enum, and it didn't even have the same value. So, wow. So we found several of these, and I was just amazed that we actually sold the product, this crap. So definitely no test coverage there. So you can be iterative on achieving conformance. You don't have to be extremist right off the bat. You can disable delayed template parsing. Throw in Microsoft compatibility switches for the Clang compiler. Ignore the type name thing. Suppress particular warnings that are very noisy in your code base, and just come back to them later when you're feeling better. Regarding the Clank-tidy checks, whole bunch of them. I think they're around 300 now. And these, I'm listing just the ones that we've successfully ran over our code base. Of course, I picked on the modernize and the readability ones. So use null putter loop conversion for range 4. Overrides was a big thing. Redundant string sister function. Unbelievably stupid usages of sister functions when initializing strings and copying things unnecessarily. Use and place, that was a nice touch. It's debatable about if it's legitimate or not in certain scenarios. Use auto, this was #1 favorite in the team. Make shared, make unique, instead of actually sprinkling news everywhere. Equals default equals delete. You wouldn't believe how many empty constructors we had there. Default member initialization, that cleaned up things a bit. Redundant member initialization, For example, lots of people feel the need to initialize standard string to nothing. I don't know why. Pass by value, brace init returns. I would pick on the worst modernizer pass I have ever seen is using. You would expect that to be the most trivial one. It really screwed up everything. I'm going to show you some details there. A lot of modernization and readability fixes around initializing strings and string comparisons. And there are some gotchas. You need to be very careful with pieces of code like this, where an actual C string function was necessary because it was passed around to a buffer that was longer than required, and it actually needed a null chart there. So we actually code that in code review and doing these automated changes. So you need to be careful with hacks in your code. Some of the problems we found, for example, a few of the unique patterns without the array specialization for make unique. We found several of these. And when using auto, it left us with some garbage in terms of orphan type defs that we used before for iterators, and auto cleaned up the initializer, but it left all those type defs that are pointless now, and we needed to clean those up by hand. So not perfect, but in modernizing range-based for loops, sometimes the iterators were hoisted above the for loop, and stuff like getting the size of the container or in a count variable, that thing that just remained unused there. So, but at least you can catch those with unused pods warning, and you can clean those up by hand. But I'm just being fair and showing you that it's not perfect. Some manual attention is required. So I said about using was by far the buggiest check we've ran, and it screwed up all our function pointers definitions, so we had to do those by hand. And in certain situations where we actually used templates, this modernizer autofix actually replaced the last template instantiation, the last type that was stamped in that template. They actually used that one when replaced the type def with the using. So it actually replaced a concrete type there instead of the template parameter. So you need to watch out for those. So beyond Clank-tidy, we wrote custom tools. We fixed, like I said, lots of member initializer lists. Removed a lot of private fields in our classes that were unused in any way and didn't have any side effects, of course. Refactored some of the heavy class constructors when we eliminated a lot of unnecessary initialization. So we're striving for W extra. We're not there yet. And we're improving the extension, and we plan to continually run stuff. And for part 3, more Clank-tidy checks. Tidy checks are organized in modules, which can be linked into Clank-tidy with minimal or no code changes in Clank-tidy. Checks can plug in the analysis of the preprocessor or with PP callbacks, or in the AST with AST matchers. Checks can report issues in a similar way, like you would see any Clang diagnostics, and can even provide automated fixes like we've seen. So you can definitely go in there and roll your own and automate the process. There are some scripts that help you set up the scaffolding necessary to generate a new tidy that you can write. And you can use tools like Clang Query to interactively prototype an AST matcher and explore the AST for a particular situation that you're trying to address. You can dump the AST and see how things are laid out and guess what kind of checks you need to provide in the AST matcher. This would be a typical layout for a tidy check that you can plug in through the existing ones. There's an LLVM Git mirror there, and you can clone it and easily build them. For example, if we're implementing a PrettyFunc Check, this is what we would have to do, and initialize the scaffolding, and this will generate test for us, will register the module, and generate the skeleton for the check source file. And this is how it would look like. You would have to inherit Clank-tidy check. And the minimal thing you would have to do if you're trying to do an AST-based analysis, register a matcher, and actually implement the check itself. So those are virtual functions that you would need to override. So these are called automatically by tidy, by the framework, and you just need to do the thing, do your magic there. If you wanted to do any processor analysis, you would have to register a PP callback. But those cases are much more rare. For example, we can bind to a function declaration. Let's say we give it an identifier as needle, and later on we can implement the check and get a hold of our needle that we matched. And for example, we can check if the function declaration starts with something like get underscore ignoring case, and issue a diagnostic in suggesting a fix to start with uppercase get and no underscore, because that's how I like it. Sure.
Is it possible to register some sort of callback that can look at comments? Like if you want to see that all your parameters are documented for your function?
Yeah. The question was, is it possible to register a callback to match code comments so that you can enforce like policies on commenting stuff? Is that accurate? Of course, it's possible. Yeah. So this is how you would invoke your custom check. I put this check in the readability module just because it's more readable to have functions with uppercase get. So this basically instructs tidy to suppress all the default checks and just run your own. That's what that syntax means, if it looks unfamiliar to you. And you can roll checks that are configurable. Many of the built-in checks have knobs that you can switch on. For example, the aggressiveness of a particular check, or some kind of class of functions that it looks for when it matches stuff. For example, if it looks for find functions or any of the derivatives, or what kind of string type to search for, or something like that. So many checks are configurable, and you can load up configurations for checks and even store them as to being dumped further on. For example, here I have two options, an integer and a string, and I just read them from the configuration. And of course, the standard way of providing check options for Clank-tidy works. You just supply the values in a .clank-tidy file, configuration file. That's just standard syntax there. I just used some symbolic names here because it doesn't fit in the slide. So this is what you would expect. And of course, you can build your check and your test unit for that check. And if you're having trouble the difficult part is actually figuring out what to write either in the matcher or in the check itself. So my example was trivial because that's about what I can do in such a amount of time. But you can dump the AST for a particular situation that you're trying to target and try to visualize the AST and pick out the right types in the AST so that you can probe them and see if you can properly identify them within the targeted source code that you're trying to modify or diagnose. So I do encourage you to write custom checks for project-specific needs. We're trying to do that. We're still learning to do that. And the most important thing is to run them regularly. Yeah. And a theme for me this week has been around strings. I've had 2 talks around strings, one around strings in COM, because there are several types of strings in COM with their particular problems, and one around string view and how I'm looking into eliminating some of these interop problems in using COM with string view, and especially if we're thinking about modern SDK like CppWinRT and its type string hstring. So I'm heavily interested in researching this issue and figuring out the good practices and all the gotchas, and actually trying to automate some of the nitty-gritty parts of actually interrupting these string types in our application and do proper data marshalling without any of the dangling references issues. So it's not easy, but I'm trying to figure this out. And yeah, we're knee-deep in COM. Our application has a very wide API surface area, and it makes heavy use of COM, and we have several types of string classes in our application, and it's always awkward when you do have to see that glue code sprinkled all over the place, and unnecessary copies being made, and unsafe constructions assuming an alternated string and stuff like that. So Clank-tidy has several string-related checks, and even one around string view. And it's a more general setting. It detects any dangling handle. Its main purpose is around string view, but it's a general check. This is one of those checks that have a configuration, and you can actually specify a different handle-like class, like string view, if you have some of your own in your code base. So it is configurable. And very hot news, lifetime profile 1.0. I'm sure Herb will mention it in a few minutes. Detecting dangling string view is an important thing, because it's such an easy way to convert from string to string view, and basically you're almost guaranteed to run into dangling references. And this is a trivial example from Herb's paper around it. And if you're running a newer version of Clang with a W lifetime switch on, you can see passing a dangling pointer as argument error there, and immediately picks up this problem in your code. And I do encourage you to see one talk today. It's at 2 o'clock. Is about implementing CPP core guidelines lifetime safety profile in Clang, the thing I just showed you earlier, the W lifetime flag. So I'm very, very interested in attending this talk, and I do encourage you to go as well. And the Visual C++ team started a new series of blog posts on their blog around Clang tooling and building with Clang. So I do appreciate this effort, and their articles are very well written, and I put a link there, and I encourage you to read it, and I'm very excited to see the follow-up articles on that. And there's a new kid on the block, another extension in the Visual Studio Marketplace that actually tries to help you build your project with LLVM. It basically gives you another tool set within Visual Studio, and you can basically switch from cl.exe and link.exe to Clang and build stuff with Clang. For example, if you want to follow in the Chromium footsteps. And with this, I'm about done. Can't wait to crash in my hotel room after I see all the good talks today. And thank you. we do have a few minutes if you have questions, or you can catch me in the hallways and I'll be happy to answer.
I just want to say a big thank you for putting Clang Power Tools out there. I'm one of your one of the 80,000 users that's totally happy.
I'm happy to hear that.
I experimented with it last spring. I've got something close to 20 million lines of legacy code. And
Wow, you're really pushing us.
no, I did about 500,000, and we picked the modernizations that we thought were just going to be really easy, sure to work, okay, and we did kind of a subset of what you put up there. But the same thing that you just mentioned is what I ran into. We thought the using substitution would be just great.
No,
And
that's
it just causes havoc.
Yeah.
Is that a bug in Clang-tidy, or
no, it's a
look at my code.
it's a bug in the check itself, not in Clank-tidy, in that particular check.
Okay.
I'm not trying to shame the author or anything, but I'm really looking forward to dig into that code.
So the interesting thing
Yeah.
is the other option I looked at is that there's an extension called Visual Assist from the whole tomato.
Yeah,
business.
we use it.
And we've used it for years.
Yeah.
Okay, and it has a subset of these moderns.
Yeah.
And their using substitution works correctly.
Yeah, but it's not implemented on top of Clank-tidy. The Visual Assist people, I've been using Visual Assist for 15 years now,
Yeah,
almost.
same with us, yeah.
So they well precede any of the Clang tools. So they roll their own. So they have their own parsers and everything. So
But, and the problem with them is they do one file at a time. So
yeah,
it doesn't scale.
yeah,
Anyway, thank you. And then
Yeah.
and one more thank you is I was on Visual Studio 15.2,
Mhm.
and there was a bug in your PowerShell script. I reported it.
Mhm.
Somebody fixed it that night, and when I came in
Yeah.
the next morning,
you can thank my buddy Gabriel back there. Yeah, he's the one that maintains the PowerShell script. So
anyway, thank you very much.
my pleasure.
So another thank you. I had almost exactly the same experience with the previous gentleman. And the other one, with the one I wanted to call out, I ran into the using type def and the .cster one. We had that happen on us, and it happened at runtime, so we were but it happened pretty fast, so it was all right. We were able to back it out.
That's tricky. Yeah.
Yeah, it is, but it didn't go to any customers, so it was fine. The other one I wanted to call out, especially that I really like, is the header reorder. That one was really nice to use for Clang format.
Yeah.
The headers in the Lego style.
Yeah.
Right, we had a lot of them where things were in the wrong order.
Yeah.
It found all kinds of ridiculous.
Exactly. Yeah.
So that was a nice one.
Physical versus logical relationship within the modules. Yeah. We've had that issue as well. So that's related to Clang format, not tidy itself. But we've encountered lots of weird dependencies and transitive includes that were not supposed to be there. So
Yeah, we're still finding them where
Yeah.
people are somehow Windows.h got in there, right?
Yeah, yeah.
Or Boost.
yeah.
Both of those two, I like using Boost, but it has a tendency to bring the world in with every header.
Sure.
So that's
I feel with you. And my colleague Theo there, he's the header hero. He actually cleaned up all our headers, so lots of work there.
it's a rough job. That
Wow,
is not
yeah.
a fun job.
No, he can attest to that.
Well,
Yeah.
thanks anyway. I just want to say thanks again because I wanted your 80,000 too, and it's been great. I want to put it on the build server and get it more automated, but I'm not there yet. So I'm just hassling people.
If we can help in any way, shout out on GitHub and
Okay.
we'll try to help you.
All right. Thank you.
Yeah.
I just had a
Hi.
practical question. If you can speak to, so you write your own Clang-tidy checks, right?
We're trying.
Enforcement, you're trying to.
We're trying.
I'm thinking like how, from a practical perspective in an organization, do you maintain that? You have, I assume, your own fork of Clang.
If you're talking about project-specific stuff, you kind of have to because you're not going to be able to do any pull requests and nobody's going to accept any esoteric check out there.
So then do you make a binary that you share on your file server or something so that everyone...
Right now, our usage of Clank-tidy in our team is on, it's a la carte, so to speak. So we're using it, if we're talking just about the tidy itself, that workflow, we're using it manually, so it's not automated or anything. And we have one or two people in the team that actually try to do those passes and inspect the diffs and It's not something that every developer on the team has installed and configured, like the Clang extension itself. So the Power Tools extension, everybody on the team has installed, and they're constantly using that workflow. If it compiles in MFC, automatically background compiling Clang so that it picks up all the warnings and errors that are Clang specific. But the tidy workflow, it's something that we do a la carte right now in terms of I periodically run it, and my friend Gabriel runs it, and we report stuff and investigate and try to patch things up. So it's not something that we need to share yet. We're not there yet.
Okay, thank you.
Yeah. Cool. So we're out of time, but you can definitely catch me in the hallways, and we can chat further if you want. Thank you.